All right, so this one, let's do minimizing. The C is 2x1 plus 3x2, subject to those constraints. And so again, what we're going to do is we are going to get our pen back, hopefully, maybe, and write A is equal to what? Well, A is going to be starting out 1 minus 2, 2, minus 1, 1, 1, and then our 2, our 3, and then our 1. That's going to be our matrix A. And then we make a transpose. And so then it's going to get taller. So we're going to have a 1, a minus 2, a 2, a minus 1, a 1, and a 1, and a 2, and a 3, and a 1. I better make sure I can read that or I'll write it wrong. All right, so now we need to make our dual problem. So our dual problem, we just write the matrix into our new problem type. So now it's going to be instead of a min, we're going to maximize P equals, and we go to that bottom row. And remember, this is x1, x2. Now this is y1, y2. And so we have max P is equal to what? 2y1 plus y2. And then we have subject to, and then we have what looks like a y1 minus y2 less than or equal to 2. And we also have a minus 2y1 plus y2 less than or equal to 3. And here our y1 and y2 both have to be greater than or equal to 0. And now we convert this to an E system. So we add our select variables, which are going to be our original variables. And so when we do that, we're going to have what? It looks like y1 minus y2 plus x1 equals 2, minus 2y1 plus y2 plus x2 equals 3. And taking all of this over to here, we have a minus 2y1 minus y2 plus p equals 0. And we have all of our y1, y2, x1, x2 greater than equal to 0. Okay. Now we convert our initial problem here into an initial tableau. So the initial tableau is just going to be all those as just variables, and we have to write it as a proper thing. So we're going to have, what do we have? We have y1, y2, x1, x2, p, and then we had x1, and then x2, and then p. And so that was a 1 minus 1, 1, 0, 0. Then we had a 2. And we had a minus 2, 1, 0, 1, 0. And then that was a 3. And we had a minus 2, minus 1, 0, 0, 1, 0. All right. So next thing, which one's the biggest negative? Well, it looks like that negative 2 is the biggest. Now notice that's a negative, so we can't use that one. So automatically we don't have to even do quotients on this one because the only one that's going to work is that one. And so that makes life a little bit easier, just one less step. So that row stays the same. So all we're going to do is going to take 2 row 1 plus row 2 goes to the new row 2. And we're going to take basically 2 row 1 plus row 3, and that's going to go to the new row 3. So that's pretty easy. Going back over here, let's go. Now this is again enter, and this one is going to exit. So now it's going to be y1, x2, p. We have y1, y2, x1, x2, p. And so first row stays the same. Second row minus 2 plus that. That's going to be 0. That's going to be what? My 2 times that. It's going to be minus 2 plus that's minus 1. And then that's going to be a 2. And that's going to be a 1. That's going to be a 0. That's going to be a 7. And same thing here. We're going to add those. We're going to get 0, minus 3, 2, 0, 1. And then add that. It should be a 4. Okay. So now we look for the biggest negative again. So that's that one. Aha, look at that. We have a negative here and a negative here. Because of those two negatives, we can't do anything. And so this one, there's no optimal solution. Okay. So sometimes that happens, and luckily it happened pretty quick, so we didn't have to do more steps, but that's how that one works out. So let's stop there and we'll come back for another one.